Hi class, in this video I'm gonna talk about the sample test for our first midterm. So the real midterm exam questions are gonna be in very similar style, topic, and another aspect. Suppose you have 2,000 and plan to purchase a 10-year certificate of deposit that pays 10% interest, compounded annually. How much will you have when the CD matures? Okay, this is a very simple question of future value of a lump sum. Okay, you are depositing 2,000 today. So from your perspective, you have cash outflow of 2,000 today at time zero. The interest rate I is 10. Okay, annual rate. How much do you get after 10 years? N is 10. Okay, we're solving for future value, and it's gonna be a cash inflow for you when you withdraw your money. Okay, you could look at the inputs in our solutions. Okay, it's all the same contents in our Word and PDF document. I'm just switching them around so it's more convenient to show the solution. Okay, for this question, the right answer should be B here. Okay, because the N should be 10 year. Okay, I should be 10. So you need to input, let me delete the percentage sign. Okay, you should, the interest rate is 10%. And in the financial calculator, you should input 10 as I. Okay, I/Y. For PV, you need to input negative. Okay, negative 2,000. For payment, it's gonna be 0. Okay, you compute for future value. Okay, let me make this a little bit wider. Okay, compute for future value. So you have 5187.48 as our future value, and you should choose option B here. Another way to solve for this question is to use our financial formula. Okay, if we go to our formula sheet, okay, we have to use this first formula sheet here. Future value N, future value after n years equals present value multiplied by 1 plus I to the power of n. Okay, so another way of solving for this first question is to use our formula. Future value equals our present value, okay, multiplied by 1 plus interest rate to the power of n. Okay, let me use this sign as showing the power. So here we have 2,000 as our present value. We can multiply by 1 plus 10% to the power of 10. Okay, we should also get 5187.48. Okay, you could always solve for all these questions using financial calculator first, and then come back, double check with formula if you have time after finishing all the questions. Okay, but either way, you should get the same option B here. Okay, let's look at question 2 here. Suppose the U.S. Treasury offers to before we move on to question 2, let me show you how to work on this question 1 using our financial calculator. Okay, I can just input 2,000 negative as PV, 0 as payment, 10 as N, and 10 as I. Compute for FV. Okay, we got option B here. Remember to change your decimal to 4, second quit, so you can have more accurate results for our exams. By pressing second format, 4, enter, second quit. Your decimal should be 4. Question number 2. Suppose the U.S. Treasury offers to sell you a bond for 667.25. No payments will be made until the bond matures 5 years from now, at which time it will be redeemed for 1,000. What interest rate would you earn if you bought this bond at the offered price? Okay, so we have the current bond price. We know the bond maturity, 5 years. We know it's a zero coupon bond. We know the par value is going to be 1,000 as the future value. We want to know what is the yield to maturity or interest rate. Okay, we're solving for I when we already know PV and future and FV and payment. Okay, so we can just use our time value worksheet. Okay, you can look at the question number 2 solution here. We can input N as 5, present value as negative 667.25, something you're paying today, payment as 0, future value as positive 1,000, and compute for I/Y. Okay, so you could get 8.43 in the financial calculator, and you add back the percentage sign, okay, and choose option D as your final answer here. Okay, it's very hard to solve this question using the formula, so we'll just use the financial calculator. Okay, so you could, let me move away the answer and move in the calculator. So you could input 667.25 negative as PV, 0 as payments, 5 as N, 1,000 as future value, compute for I. Okay, we have option D here. All right. Question 3. The interest rate is 8% annually. How long does it take for the money to triple? Okay, we had a similar question about how long it takes the money to double in our note. Okay, here it's triple. So we can assume any number that's tripled. Okay, so here we can assume that we're investing let's say 1 million. So the number is 1 as our present value here. However, our future value is going to be 3. Okay, so but these two numbers should be opposite signs. So let me assume I'm having cash outflow of 1 today, input -1 as PV, and I have 3 as my future value, as my cash income. Payment is 0. I is 8. Okay, because the interest rate, annual interest rate is 8%. Compute for N, I get 14.27. So it takes option E, 14.27 years to for the money to triple. Again, it's hard to use a formula to work this question out. So if we use financial calculator, input 1 negative as PV, 3 as FV, 0 as payments, 8 as I, compute for N. Okay, we have 14.27. Number 4. What is the PV of annuity due with 5 annual payments of 8,600 and an interest rate of 5.5%? Okay, let's look at this question. It's asking for present value of annuity due. We had similar practice or example in our notes. Okay, here we need to change to begin mode by pressing second. Okay, we need to press second begin, which is the same button as payment. Second set, second quit. Okay, so on the screen, you see BGN here. Okay, so for begin mode, we need to press second begin. We need to press second begin, second set, and second quit to change to begin mode. Okay, and we input n as 5, interest rate as 5.5, payment as 8600, okay, future value as 0, and compute for present value. Okay, we should be able to get negative number as our current money we're paying if we are withdrawing 5 payments in the future. Okay, so we choose option A. This is the present value we need to pay if we want to receive 8600 for 5 years. Okay, let me show you on the financial calculator. Now I'm in the begin mode and I input 5 as n, 8600 as payment, okay, and 5.5 as I, and future value as 0, compute for PV. Okay, I have option A. Okay, remember, after you work this question out, most of the questions we have are for ordinary annuity. So let me change back to end mode after I finish an ordinary annuity do question. After I finish an annuity do question, okay, by pressing second begin, second set, second quit until you see nothing on the screen. Now I'm back to end mode. Okay, so after I work, so first I change to begin mode and then I do all the calculations, okay, and as my last step I change back, okay, for the future questions I change back to end mode by pressing the same buttons. Question 5. What rate of return would you earn if you paid 30/80 for perpetuity that pays 85 per year? Okay, we have to use formula for perpetuity question. Okay, so if we go to perpetuity formula, present value of perpetuity equals payment over interest rate. Okay, so here in this question, we're looking for I. We know payment and PV. Okay, so if we look at the answer here for question 5, okay, because present value of a perpetuity equals payments divided by I, so here I would be equal to payment divided by present value of a perpetuity. Okay, and we know our payment is 55 in this question. Our present value is 30/80. We can get 2.76% by dividing them. Okay, so we can just use 85 divided by 30/80. So we have 0.0276, which is 2.76%, option C. Okay, so what we get is 0.0276, and we need to change it to the percentage format. Okay, remember this is just using the financial calculator as a scientific calculator here. So we don't just add the percentage sign directly. We need to make real mathematical conversion here. Okay, this is not in the TBM worksheet. This is just using the financial calculator as a scientific calculator, as a regular calculator. All right, question 6. You sold a car and accepted a note with the following cash flow streams as your payment. What was the effective price you received for the car, assuming an interest rate of 6%? So you have uneven cash flow here. Okay, you have 4 uneven cash flow here, and you have interest rate of 6%. You want to know the present value. Okay, we need to use the uneven cash flow function on the calculator. Okay, so we need to use the cash flow function, and for cash flow 0, it should be 0. Enter. Down button. Cash flow 1 should be 1,000. Enter. Down button. Frequency 1. Cash flow 2 should be 2,000. Enter. Down button. Frequency 2 should be 3 because we have 3 2,000. Down button. We should not have cash flow 3. Let me enter it as 0. Cash flow 4, 0. Okay, come back to cash flow 0, nothing else. And then I press MPV, input I as 6, enter, down button, compute. Okay, so I get option A here, 5987. Okay, or 5986.81. And it rounded to option A. So I just use cash flow and MPV function to solve for uneven cash flow questions. Okay, let me write this down in our Word document as our solution here. Here we have I as 6%. Okay, we have all these uneven cash flows. Okay, the solution is telling us that we could actually also solve for this question by using formula, by discount all these cash flows one by one, by using 1,000 divided by 1 plus 6%. So we have 943 as the present value of the first cash flow. We could use 2,000 divided by 1 plus 6% square. So we have the present value of the second cash flow, so on and so forth. And we add up all the present values of all the cash flows. And we add them up. So we have 5987. Okay, so we can solve this question by summing individual present values or using the calculator MPV function. We could also use Excel, but that's not what we're covering in this course. So let me delete this row here. Okay, so if we're using the calculator function, what we need to do is to press cash flow function. Okay, press cash flow, input cash flow 0 as 0. Okay, cash flow 1 as 1,000. Down button. And then press cash flow, enter cash flow 2 as 2,000. Down button. Excuse me. After we input cash flow 1 as 1,000, we need to input frequency 1. Okay, frequency 1 as cash flow 1 is CO1 as well. Okay, FO1. Frequency 1 as 1. Okay, down button. And cash flow 2 is 2000, down button. Frequency 2 is 3. Okay. Down button. And check there are no other cash flows. Okay. It means cash flow, but it shows CO here. Okay, and then we press NPV, okay, and input I as 6. And then down button, compute NPV. Okay, that's how we can get this number here. Okay, that's question 6. Question 7. You agree to make 24 deposits of 500 at the beginning of each month into a bank statement. At the end of 24th month, you will have 12,850 in your account. If the bank compounds interest monthly, what nominal annual interest rate will you be earning? Okay, so this is making deposits at the beginning of each month. So again, this is a annuity due question. Okay, so first step, you need to input or change your mode to begin mode. Okay, so it's similar to question 4. Okay, let me put here that's for question 7. You also need to change to begin mode first by pressing the 3 buttons. Okay, and then here you need to input N as 24, PV as 0. Okay, because you're not depositing anything today besides the payment 500 from the beginning of each month from today. Okay, so we input PV as 0, payment as 500, and we also input future value as 12,850. Okay, but remember, the 500 payments are something you're depositing for 24 months. So this is cash outflow for you. Negative 500 should be payment. For this future value 12,850, that's something you're going to receive after 24 months. So we make it positive. Okay, these two have to be opposite numbers here because you are paying something over the 24 months and then getting something after 24 months. Okay, and then the I/Y, the monthly rate would be something you are calculating for. Okay, we compute for interest rate per month. It's still gonna be the I/Y button, but it means interest rate per month. You're gonna get 0.54 on the calculator. So you add back the percentage sign. The monthly rate should be 0.54%. And then you multiply by 12. Okay, you use 0.54% multiplied by 12. So you have 6.52. Okay, as your final answer for this question. Option E. Okay, let me just compute for I/Y so you know that's the button. That's the answer you need to compute for. And you get this number 0.54, and you add back the percentage sign and you multiply by 12. So you have this 6.52 as the nominal annual rate. Okay. and you change back to end mode. Okay, always remember, change back to end mode by pressing the same buttons. Okay, let me show you on the calculator here. All right. All right, let me input n as 24. Excuse me, let me quit and then start with the TVM worksheet. 24n, okay, and then 500 negative as payments, 12850 as future value, okay, and 0 as present value, compute for I. Okay, 0.58596. Let me computer again. 5896. Huh. Oh, let me double check. So for this question, I haven't changed to begin mode yet. Okay, so excuse me for that. The first step should be second begin, second set, second quit. Okay, now we compute for I. Compute for I. Now we have 0.5433. Okay, and then I use this 0.5433 multiplied by 12. So I have 6.5196, which is option E. Okay, and then I change to end mode. Question 8. MasterCard and other credit card issuers must by law print APR on their monthly statements. If it's 18% with interest paid monthly, what is EFF? Okay, so for solving for effective annual rate from nominal annual rate, we can use second interest conversion worksheet. Input nominal rate here as 18, enter, down button, effective annual rate, wait a second, down button, C/Y, compounding periods per year. Here it's monthly compounding, so let's input 12, enter. Up button, compute. Effective annual rate should be option C, 19.5618. Another way to solve for this question is to use our formula here. Okay, it's in here. Effective annual rate is 1 plus nominal rate divided by m to the power of m minus 1. So we can use this 18% divide by 12 plus 1 to the power of 1 minus 1. Okay, using the formula, we could also get the effective annual rate as 19.56%. Okay, so method 1 is our formula here. Okay, method 2, using our financial calculator, we can press second ICOMV, which is the same as number 2 button. Okay, and input NOM as 18, down button, twice, go to C/Y. Okay, we enter it as 12, up button, compute for our effective annual rate. That also gives us the same number, 19.56. Okay, there are 2 ways to solve for this question. Number 9, we have or your company has just taken out a 1-year installment loan for $72,500 and a nominal rate of 9%, but with equal end-of-month payments. What percentage of the second monthly payment will go toward the repayment of principal? Okay, so this is testing us the knowledge of amortization loan. Okay, the most convenient way is to use our financial calculator to solve for the monthly payment first, and then use our amortization table to solve for the second monthly payment percentage for repayment of principal. Okay, so our first step is to solve for the payment. Okay, we could input 72,500 as present value. Okay, and the nominal rate should be converted into the monthly rate. Okay, so we can use 9 divided by 12 as 0.75 and input that as our I, the monthly rate. Okay, and then our future value should be 0 after we pay back all the loans. And our N should be 12 because it's a 1-year loan. We have 12 months and we compute for payment. Okay, the monthly payment should be 6340. Okay, then we can go to second amortization table. We want to know the second month payment, so we change P1 to 2, enter, down button. P2 should also be 2, enter, down button. We know the ending balance of the second month now. We also know the principal payment for the second month. Okay, so it's gonna be 5839.9557. We also know the interest payment we are paying for is 500 for the second month. Okay, so now we can just use this principal payment 5839 divided by the total payment we just calculated out. Okay, remember the total payment? 6340. Okay, we divide these two numbers, we should get option B, 92.11% of this total 6,340 is the principal payment. Okay, let me repeat the process using the solution here. Question 9. Okay, first step 1, calculating. Step 1, calculate the monthly payment. Okay, by using the calculator. N is 12. R, because the nominal rate is 9%. Okay, so the periodic rate is 9 divided by 12. So we have 0.75 as our periodic rate. Okay, so we input I/Y as our periodic rate. Okay, you're gonna see all the additive solutions in our document later. Okay, this is something information we have, not the inputs in the calculator. So let me put it in a bracket. Present value is something we're getting today. So it's a positive 72500. Payment is what we want to compute for. Okay, so we actually, so future value is 0. That's what we want to input. And then we compute for payments. Okay, we get negative payments. That's something we're paying for 12 months. Negative 6340. Okay, and then we go to step 2. is to calculate the second month payment that goes toward the repayment of principal. Okay, we can do this by using second amortization. Okay, by pressing second amortization on the calculator, we can see P1, and we set P1 equals P2 equals 2. So we check the monthly payment down button. Okay, down button, I think we need to press it until press down button multiple times until you see PRN. Okay, and it actually shows PRN, the principal equals negative 5839.9557. Okay, that's gonna be the repayment of principal in the second month. Second month repayment of principal is this much. Okay. Step 3 is to solve for the percentage of principal. Step 3. Solve for what the question is asking for. Okay, the percentage of second month repayment of principal. Or the percentage of second month payment that goes to repayment of principal. Calculate the percentage. Okay, step 2 is asking or calculating the actual amount that goes to toward the repayment of principal. Step 3 is asking for the percentage, and we use the amount we saw from step 2, principal month 2, which is negative 5839.5. We're using this number from the second step, divide by the total payment in the second month from the first step. Okay, so we use 5839.9557 divided by 6340. So we could have the final answer of 92.11. They're all payments, so they're all negative, but when we calculate percentage, we don't have to use the negative sign. Okay, here we go. We can just use the 5839.9557 divided by 6340, the total payment. Okay, principal repayment divided by total payment is percentage of principal payments among the total payment. Okay, an alternative way to solve for step 2. Okay, calculating for the repayment of principal in the second month. Calculating the principal repayment in the second month is using amortization table. Okay, instead of using this second amortization table in the financial calculator to solve for the principal payment in the second month, we could also construct the amortization table. Okay, remember, we can just begin from this first month. The beginning balance is 7,500. Okay, we put it as the beginning balance in the first month, and we know the total payment in the first month is 6,340. The interest payments should be the beginning balance multiplied by the interest rate, 0.75% as the monthly rate. Okay, that gives us 543.75. Principal payments would be the total payments minus the interest payment. And the ending balance would be beginning balance minus principal payment. And then the beginning balance of the second month is going to be the ending balance of the first month. Okay, same payments in the same total payment in the second month. Interest in the second month should be the beginning balance of the second month multiplied by the monthly rate. And then the principal payments would be the total payment of the second month minus the interest payment in the second month. Ending balance of the second month would be the beginning balance of the second month minus the principal payment. So we can also get this number from the table, 5839.96. And then we divide by 6,340. We can also get this percentage here. Okay. You could refer to our chapter 5 and 6 class 4 notes for how to construct an amortization table or how to use the amortization table function in the financial calculator. All right, question 10. Assume that interest rates on 20-year Treasury and corporate bonds are as follows. Treasury bond is 7.72%. AAA bond is 8.72%. A bond is 9.64%. BBB bond is 10.18%. The differences in these rates were probably caused primarily by. We should choose option C here. Default and liquidity risk differences. Remember, Treasury bond has the lowest rate of return here because it has lowest risk. It has almost zero default and liquidity risk. Okay, DRP and LP is almost zero for Treasury bond. And for other corporate bonds, the lower the rating, the riskier the bond is. So we have higher required return for the bond. Okay, because for lower rating bond, there is a higher default risk and liquidity risk, so the return and the risk are higher. Okay, this is not about real risk-free rate. Real risk-free rate should be all the same, or risk-free rate should be all the same for all the bonds. Maturity risk should be just different for bonds with different maturities, but these are all 20-year bonds, so they should have the same maturity risk. Inflation should be, IP should be all the same for all the bonds. Tax effects, not relevant here. Question 11. The real risk-free rate is 3.05%. Inflation is expected to be 4.25%. Maturity risk premium is 0. What is the rate of return on a 1-year Treasury bond? Okay, so we can just use a formula for a short-term Treasury bond. Interest rate of a bond equals real risk-free rate R star plus inflation premium plus default risk premium plus liquidity premium plus MRP maturity risk premium. Because this is a 1-year Treasury bond, we do not have DRP or LP because this is a Treasury bond. We also do not have MRP because this is a short-term 1-year bond. So we end up with just R equals R star plus IP. And we already know R star and IP in this question. Okay, so 11 is simple. We just use the R star, real risk-free rate 3.605% plus inflation premium. Okay, so let's look at the solution in the document, in the Word document. We have R star given 3.05%, inflation premium given 4.25. So 1 year bond interest rate is just R star plus IP. So we have 7.3%. Okay, so we have option B, 7.3%. Okay, a more theoretically more precise answer is just use 1 plus R multiplied by 1 plus IP minus 1. We didn't talk about this in the lecture, so we can just ignore this for now, because this question also says that we ignore any cross product terms. Okay, so let me just delete this row. Question 12. We have a 10-year corporate bond. It has a yield of 8.75%. R star is 2.5%. Default risk premium is 0.25%. Liquidity premium is 1.65%. Maturity risk premium is 1.15%. What is the inflation premium? Okay, so it's a long-term corporate bond. So we need to use the comprehensive formula because this is a long-term corporate bond. So we do have MRP because it's a corporate bond. So we also have DRP and LP. Here we're looking for IP. It should be the total interest rate R minus R star minus the other three premiums. Okay, we move IP to the left-hand side of the equation. So we only keep IP on the right-hand side of the equation. So it equals what's on the left-hand side, R, minus all the other four elements. Okay, and we know here in this question, the total return is 8.75%. We can use this to minus R star, 2.5%, minus MRP, which is 1.15%, minus DRP, which is 0.25%, minus LP, 1.65%. So we have 3.2% as our final answer. We should choose option C. Question 13. We have a bond that matures in 8 years with a par value of 1,000, annual coupon interest rate or annual coupon payment of 65. Market requires interest rate of 7.3%. What is bond price? Okay, so for this question, we can just treat this annual coupon bond, solving for the bond price PV and input all the other four informations in the financial calculator. Okay, N should be 8 years, I should be 7.3 annual interest rate, payment should be 65. Okay, future value should be 1,000. Both the payment and the future 1,000 par value are something you're receiving, so you input as positive, and then you compute for PV, the bond price. You should receive a negative number, and then we choose option B. Okay, so let me repeat the process here. 8 as N, 1,000 as FV, par value, 65 as payments, 7.3 as I, compute for FV, PV. Okay, we also get option B. Question 14. This company's non-callable bond sells for 1110, 15-year maturity, annual coupon 85, par 1,000. What is yield to maturity? Okay, very similar for an annual bond. Now we're looking for yield to maturity, I/Y. We would like to compute I/Y in the end after we input all the other information or variables. And here should be 15 years. Present value should be something we're paying today, price, negative 1110. Payments, something we receive as coupon, 85 for 15 years. Future value, something we receive after 15 years as 1,000, par value. Compute for I/Y, we can get 7.27. And we add back the percentage sign, choose option E as our yield to maturity. Okay, so I could input 1110 negative as PV, something I'm paying today to buy the bond. I know it's 15-year as N. I'm receiving 85 as payments for every year at the end of each year. 1,000 as future value, par value after 15 years. That's what I'm receiving. Compute for I, 7.27, option E. Okay, question 15. Last question here. This bond sells for 1030, par value 1,000, 105 annual coupon, 15-year maturity. They can be called in 5 years at 1100. What is yield to call? Okay, so here we can just input the years to call instead of years to maturity because we're solving for yield to call. Okay, so we input 5 as N, and we input still bond price, negative 1030 as PV. Payment is annual coupon payment, 105. Future value, it should be the bond call price, 1100 instead of the par value. And then compute for I. Okay, compute for I, we should get the yield to call, 11.28. Add back the percentage sign, we choose option B. If I do it in the calculator, again, we input 1030 negative as PV, bond price, 5 years to call as N, 1100 call price as future value, 105 as payment. Okay, and then compute for I. Okay, option B.